So now that we have understood the meaning of the term vector, let us understand some basic concepts on vectors. So here we have a point A, a B, and we have a line segment AB. So in the line segment AB, if we give the direction from A to B, A is said to be the initial point and B is said to be the terminal point. And this line from A to B, this is called a directed line segment because it has magnitude as well as direction. So here comes vector again, and we can name the vector AB as A bar or A vector. Now let us understand another term, which is position vector. Suppose we have the three axes, the x-axis, y-axis and the z-axis, and we have a point P which is x, y, z. Then this OP vector is also known as the position vector of P with respect to the origin O. Now we can find the magnitude of this position vector. That means we can find the length of this vector OP or OP vector. How to find the length of this OP vector or how to find the magnitude of this OP vector? We are going to use the distance formula that you have already studied in your class 11. What is the distance formula? It is root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this distance formula can be applied in this situation and we can find the magnitude of the vector, or you can also say the length of the vector OP. So your magnitude will become root over x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. Now why did we mark 0, 0, 0? Because the first point is your origin, that means x1, y1, z1 is your 0, 0, 0. And why did we mark x, y, z in the distance formula? Because the second point, which is your point P, is x, y, z. That means x2, y2, z2 is your x, y, z. So we have applied all these values in your distance formula. And ultimately, your final answer is coming out to be magnitude is equal to root over x square plus y square plus z square. So we can find the magnitude of any vector. Now vectors have one more part. The first part was magnitude, which you have already seen how to calculate, and the second part is direction. So how to find the direction or the position of a point, position of a vector? So let us understand with the help of this diagram. Suppose we have the x-axis, y-axis and the z-axis. Now we have a point P in space and the coordinates of the point P is A, B, C. That means in our diagram we are marking OA, which is equal to A, OB is equal to B and OC equal to C. So now we can join the vector OP. So OP is actually your position vector and we are marking it as R vector. Now this OP vector or the R vector is making angles with respect to the positive x-axis, which we are calling alpha. It is also making an angle with respect to the positive y-axis, which is beta, and it is also making an angle with respect to the positive z-axis, which is gamma. Now if you concentrate only on that small triangle OAP, what are the values that you know? OA is equal to A. The angle made by OA with respect to OP is alpha, and also OAP is a right angle triangle. So you have to imagine this diagram. Now in this triangle, which is a right angle triangle, you can use the cosine formula that you have learnt in your trigonometry chapter. That means cosine of alpha will be equal to base by hypotenuse. What is the base in this triangle? It is A. What is the hypotenuse in this right angle triangle? It is R. So that means cos alpha will be equal to A by R. And if you shift the terms, now you will get A equal to R cos alpha. Now this cos alpha, we are calling it as L. So you will have A equal to LR. In the same process, if you take other two right angle triangles, you are going to get B equal to MR and C equal to NR. Again I am repeating, what is L, M and N? They are cos alpha, cos beta and cos gamma. And this cos alpha, cos beta and cos gamma are also known as direction cosines because they will give you the position of the point P. That means these direction cosines will give you the position of a vector or the direction of a vector. So we had A equal to LR, B equal to MR and C equal to NR. Now in the point P, instead of writing P, A, B, C, we can write it as P, LR, MR, NR. So in this way, we can find the direction cosines or the direction of a vector. So we have seen how to find the magnitude of a vector and also the direction of a vector.